Hello, good morning to கேக்குதா அபிஜித் போடுறது? Okay, okay, so good morning to all. So today we can see the EV introductions, so on the vehicle dynamics, so and also the MATLAB simulations. So if you have time, you shall see the MATLAB simulations. So before going to the MATLAB simulation, we have must to know what is EV, why we need the EV, and the things are we can check. Okay, so first of all, electric vehicle. So what is mean by electric vehicle? So electric vehicle is nothing but so the vehicle propulsion carried out by the motor. Okay, so by using rechargeable batteries or non-rechargeable batteries, so called electric vehicle. Hello, I'm audible. I am audible. Yeah. Okay. All right, we can start. So if the vehicle propulsion carried out by the motor. Okay, so by using the rechargeable batteries or non-rechargeable batteries, so called electric vehicle. So apart from the battery, some alternative energy sources also available. Okay, what are they called means solar panels, fuel cells, and electric generator, etc. So these are all the another energy sources by using electric vehicle. So okay, so in these classes we can see the basic system of EV. What are the components using in EVs? So how we can work? So all things we can seen in these classes. Okay, so why we need electric vehicle? So first of all, first one is so pollution. Okay, so why need electric vehicle means so first two concept is pollutions. So compared to IC engines, so electric vehicle does not create the pollutions. Okay, so second thing is there is no large number of moving parts. So compared to IC engine, there is no less moving parts. Okay, so these are the comparison here. So no tactile emission means there is no emission. So while running the vehicle, but using petrol or diesel means we have the pollutions. Okay, NOx emission. We have the emission, the NOx emissions. So we can utility company. So we can get from the charging station. So utility company. So we have to buy the petroleum. So operational petroleum corporation we have to buy the petrol from abroad. So range is now nowadays using 300 plus mile range. So here also 300 plus mile range. So hours to recharge take more time. Okay, hours to recharge take more time compared to IC engine because of we can refueling the fuel in 5 to 10 minutes. 5 to 10 minutes. Recharge hours takes to 6 to 8 hours. Okay. So electric vehicles have a very low moving parts compared to IC engines. That also there is no noise and vibration. Okay. So carbon emission from the electric vehicle is very less compared to conventional vehicles. I already told that. So it will reduce the deficiency of oil because the other fossil fuels will be not available in future. So in future there is no petrol because of crude oil as a very less. So from the crude oil we can take the petrol, diesel, wax, etc. Okay, so in future it's maybe very less. So that are one reason to moving the next sources. Okay, so EV. So EV is nothing but electric vehicle. So vehicles are either partially or fully powered by the electric power. It's called EV. So electric vehicle have the low running cost because of they have the less moving particles. So environmentally friendly. They use little no fossil fuels. Okay, so that can be very easy. So some EVs are used in lead acid. In Asian days, we can Asian days, not Asian days. Some before days we can test the EV by using lead acid batteries. So nowadays we can using the lithium ion and ferrous phosphate in future. So nickel metal hydride batteries also used in this EV. Okay. So nowadays use the modern batteries. So lithium ion. So currently we can use lithium ion. So future we use the ferrous phosphate batteries also. Okay. So history. So in last 100 years we have used the IC engines in run to vehicles. Okay. In India we can use the IC engines to run the vehicle. That's why we are feeling electric vehicles are fully neat concept. Okay, but the fact is difference. So during 1980s to 1990s, so there were electric taxi used in London and New York in 1980s. But on one more interesting fact means first designed electric vehicle. So the first designed electric vehicle, world record speed of 100 plus range, 100 plus range. So 100 plus range to maximum speed. Okay, so this is the first EV car. So crossed the 100 kilometer per hour speed in 1899. So that you can see. So 1899, we have reached the 100 plus speed. So the name of the car. So the brand of the car is La Jamis Content. Jamis Content. So driver name is Camry Densency. Camry Densency. So this is the first designed EV. So driver by single member. Okay. So this is by first EV. So next one is 1830. In 1830, the first electric garage was built by the non-reusable battery. So this is the garage. So this garage was the non reusable batteries. Okay, so we can use the single type batteries. So using this in 1890, William Morrison assembled the first electric automobile in US. Okay, in 1890. Okay, in 19 to 28% of car we have produced the electric drivetrain in United States. Okay, in 1900, 28% of car we produce by the electric drivetrain by in United States. So the next time is so in 1970, city car was built by the Vanguard Cybertruck. So city car, so van city car. So nowadays it's the same model. We have used the MG. Okay, only two members you can drive in vehicle. You can see in your area. So MG Vector, the name is MG Vector. So same similarly car. So in 1970, city car was built by the Vanguard Cybertruck. The vehicle has a 30 miles per hour and the top speed is of 40-mile range. Okay, so first two members EV car. So in 1990, General Motors introduced the electric vehicle. So named is EV1. Okay. So in 1997, Toyota introduced an electric vehicle called Toyota Prius. So this is the first commercially mass produced electric vehicle in India. Sorry, not India, in US. Okay, sorry, in US. In 1997, Toyota Prius is the first commercial electric vehicle. So you know the first electric commercial version. So developed by the Toyota. So the car name is Toyota Prius. Okay, here. So here the car, so Toyota Prius in 1997, so first commercial vehicle. So, but in 2000, directly in 2018, so Tesla Motors launched the electric powered sports vehicle, so race car. So Tesla is the first company nowadays also Tesla is the first company to rule the electric vehicles. Okay, so to rule the electric vehicle, it is called Tesla Roadster. So 2018 model is a Roadster. So they that used to launch the commercial vehicle. So directly launched a sports in 2008, so sports car. So what is this the first sports car? So in nowadays also Tesla is the number one brand company in EV. So next Jaguar, Rolls-Royce, that's all difference. But the first rule in EV means Tesla Roadster from 2008 to still. Okay. So this is the history of EV vehicles. So now see the benefits of electric vehicle. So the energy efficiency of the electric vehicle is higher than the conventional vehicle. Okay, I already know. So compared to these benefits are compared to the ICE engines only. So electric cars will be reduce the carbon emission. So because of there is no emission while driving, but manufacturing it may be some emission. So for manufacturing lead acid battery means it take the more emissions. So compared to ICE engines. But while driving means there is no carbon emission. So compared to ICE engines. So fuel cost is very less. Okay, I already know. So nowadays petrol rate 102, 101 liter per liter. But unit cost means commercial means 8 to 9 rupees. So in usage means 4 to 5 rupees only. So depend upon the usage. So fuel cost is very less compared to IC engines. So drive system also very simpler. So because of if you're in gearbox means you can use the gearbox. So motor to difference unit. So difference unit tire. So this is a concept. But use a gearbox means a motor to gearbox to difference unit to wheel. So this is a transmission line. So drivetrain. So that's why drive system is very simple. So regenerative braking also available in EV. Okay, so regenerative braking is nothing but so when drive a vehicle in free manner, so vehicle rotates in free. Likewise means when a vehicle drive in slope condition, we have to create the regenerative braking systems. Okay, so sorry for the disturbance. So these are the benefits. So next we can see the challenges. So every vehicle have the challenges also. So in EV, what are the challenges means? So range is very less compared to IC engines. Okay, so why compared to distance means when we tank full the petrol means we have drive ranges of 500 to 600 kilometers. So depend upon the car. But in EV means you have the only nowadays 300 kilometers plus 400 kilometer only you have the range. So that's one challenges. So refueling is more important in electric vehicles. So because of when using the petrol means we can refuel the within 5 minutes we can refuel the vehicles. But in EV what means minimum hour we can 6 to 8 hours we have to take to charge the battery. 0 to 100% we have to take the 8 hours minimum 8 hours. So depend upon the battery capacity. So cost of the electric vehicles is more expensive. So compared to the conventional vehicles. Okay, so because of we can buy the batteries in abroad. So battery is the main cost of the EV vehicle. So battery, motor, controller. So we have the main cost of EV vehicles. So the cost is very expensive. Okay. So energy sources. So these are all the energy sources we can get from the power. So we transfer the energy from the electric vehicle charging through via renewable sources. Then we can reduce the emission from the environment. Okay, so we can speak about the renewable energy means. So these are the examples. So solar energy, we already know. So what is meant by solar energy? We can get the power from the sun. So this is solar energy. So wind energy means we can using the blades to generate the electricity. So hydropower. So hydropower is nothing but we can use the dam in dams. We can use the nozzle to strike the blade. So it will rotate. We can generate the power. So tidal is nothing but create a artificial wave to generate the power. So create the artificial wave to strike the wall to create some power. So the tidal energy. So biomass energy is already no. So wastages, we can dump the wastages. So after some years, we can take some gases. So then the gases we can get from the power. So that is a biomass energy. So nuclear this is very cost, but long lasting. Long lasting means more power. So only one is enough to drive the electric vehicle, but it is very more harmful. So it blast means surroundings area will be very dangerous. So nuclear energy is maximum not possible. But compared to all the energies, nuclear energy is very more expensive and high. Okay, so electric vehicle technologies. So electric technology means these are the electric vehicle types. Okay, so based on the energy resource condition, so electric vehicles are cast into maximum these four types only. So four types. So fuel cell is a working condition vary, but maximum is three types. So these three types very important. So one is battery electric vehicle. So second one is hybrid electric vehicle. So third one is plug-in hybrid electric vehicle. So fourth one is fuel cell. Okay, so we can see the one by one. So we can see. So first one is battery electric vehicle. So battery vehicle nothing but a BEV. So we can be run by the battery and the motor. So hybrid is nothing but two energy sources. So one is gasoline engine. So gasoline engine is IC engine. So one is electric motor. Okay. So it can be rechargeable while driving the IC engines. So we can get the power from the battery to charge. So non-plug-in. So next one is a plug-in. So plug-in is how to. I can say one by one. So this example we can see. So next one is battery electric vehicle. So electric vehicles only battery is a energy source. I already told you. So BEV means so fully electric vehicle. So fully electric is nothing but so the range of the electric vehicle is directly posed to the battery. There is no any another engines. So only electric motor, battery, uncontrolled, pure BEV. So okay, energy. So only the energy source is battery. So simple service, the energy source is battery. So the common BEV drive range is nowadays so 300 plus for a mile range. So near 400 kilometer drive range. So nowadays. So the charging time depending upon the charger configurations. So operating level and infrastructure. So that need nothing but so capacity in battery. So we can 0 to 100% means we take the more than 8 hours. So in 50% we can charge means take the 4 to 5 hours. So that is charging depending upon the battery capacity. So battery capacity also. So this is a BEV. So hybrid vehicle. So hybrid is nothing but combination of two sources. Okay, hybrid also the combination of two sources. So here the what are the two sources means IC engine and battery pack. So here the two sources is IC engine and battery pack. So these are the two energy source. So here the during low speed we can use the motor. So during high speed we can use the IC engines. So this is a concept or not concept. So before introduce the market one vehicle. So we can produce a new source to introduce the market means we can introduce with the hybrid. Okay, we can test with the hybrid. How means so not only BEV. So example means example not CNG. Okay, so first we introduce the CNG means so IC engine. So petrol tank capacity is 20 liter. So CNG tank capacity is 2 kgs. So after that update means so engine capacity, so diesel in petrol capacity was 10 liter. So CNG capacity 5 kg. So we can into so after that finally so only CNG run vehicle means the tank will be 10 kg or 20 kg whatever we can use for CNG. So likewise we can introduce in the market. So that is a concept. So that's a concept. So widely you can use means when use the petrol means we can drive in IC engines. So after the petrol empty, we can use the battery to reach the petrol bunk. So this is a usage in India. It works tell in examples. Okay. So how the electric vehicle boost will reduce of gear shift means the IC engine also called the charging capability while driving because of engine and electric motor coupled. Okay, so engine and motor would be coupled while engine running, motor also rotating. So motor would be no low rotating. That the time motor generate the power. So motor act as a generator. Okay, so create electricity. That electricity we can convert the battery. We can charge. So it's called a regenerative braking system. So it's a software in MATLAB software means theoretical it can be possible, but actual means maximum is not possible because of the generate voltage is very less. So come depend upon the battery capacity. So for example means so battery capacity 12 volt. So I tell the example. So the battery capacity is 12 volt means so generate voltage is 4. Okay, so generate voltage is 4 voltage. That but message we can get to charge the battery because of while we battery the charge means we can do the higher energy. So higher energy compared to battery. So for example, tell means so 12 volt battery means so we can give the 13 to 14 volt to charge the battery. Okay, so while charging, but to generate the 3 voltage, 4 voltage means we cannot enough to charge the battery. But theoretical means it can be possible. So that is a re-energy regenerative. So testing is under process. The primary energy source of drivetrain is IC engines. So while means the primary energy source means nothing but so mainly use the IC engines. So secondary we can use the battery, so motor. So that is a secondary concept. So plug-in hybrid vehicle. So like they tell right. So plug-in hybrid nothing but so primary energy source is the battery. So secondary energy source is the IC engine. So how that means nothing but so battery capacity will be high compared to hybrid vehicle, and the fuel tank will be less. We can give the only 5 liter capacity to IC engines. So carbon emission is very less compared to hybrid electric vehicle because of the majorly. So primary source is battery. Well, vehicle drive in battery. So in case any emergency in case, you can use the IC engines. So the primary energy source is a plug-in hybrid electric vehicle. Okay, so the final one is a fuel electric vehicle. So fuel electric vehicle nothing but so it is working under the chemical reactions. So this is the pure carbon emission vehicle. Okay, why I tell that? So fuel cell produce electricity by use of chemical reaction without any combustion. So how means so hydrogen and oxygen. So byproduct of reaction is water. So we can create the power by using the hydrogen and oxygen. Okay, so hydrogen on cylinder, oxygen on cylinder, we can insert to the capacity. So it will be under the chemical reactions. So occur so chemical reaction occur. That time the byproduct of water will be created. So create some energy. So that energy is stored in the battery or supercapacitors. While time we can drive the vehicles. So fuel cell car also available not in India. Fuel cell car available in the New York and US. Buses also available. So how means the Ashok Leyland company so created the fuel cell buses for New York, not drive in India. So fuel cell buses is available. So in New York, we can check with the Google. Okay, so this is a pure carbon emission vehicle. Okay, so there is no reaction because of there is no any reaction. So automatically we can use hydrogen and oxygen only to create the chemical reaction while to running the vehicle. Okay, so this is a fuel cell electric vehicle. Fuel cell electric vehicle. Okay, so these are the types we can see in one by one. So next is drivetrain configurations. So drivetrain configuration nothing but how we can connect the vehicles. Okay, so first one is the electrical configuration with the motor, clutch, gearbox, and the differential. So we can connect with the series. So motor connected to clutch plate. So clutch plate connected to the gearbox. So gearbox connected to the differential unit. So while we run the vehicle, differential connected with the wheel while driving. So the electric vehicle without clutch and gearbox means so motor to this is simple gear. It will name as a simple gear. So for front and back. So when move the front and back. So simple gear. So simple gear connected to the differential unit while drive the vehicle. Okay. So these are drive combinations. So drivetrain without clutch gearbox in parallel circuit. So parallel means well create the series connection. We can before we can see the series connection. So here we can see in parallel. So parallel to the motor. All are connected in single differential. So single differential unit. So motor we can connect in a single action. Okay, it can get the more power. So in loaded vehicle, so we can connect the motor so parallel to the differential unit. Okay, so that's one concept. So here the two different motors. Okay, so for both wheel. So motor gear wheel motor gear to wheel. So because of so it is very useful. So in this type we have one car Nissan. Okay, not exactly. So Nissan electric vehicle one available for this model. Okay, so it is very useful to rotate the car in one room. Like that means when rotate the vehicle opposite direction, it will be drifted so easily. We can turn in the very smallest area also. So that's concept. So heavy load we also combined very easy. So this is a concept of two motors. So different two motors for different speed to get the higher efficiency to get the more power. So loaded vehicle we can use the these types of concepts. Okay, so these are the EV introductions. So regarding any doubt, we can move to the next topic. If you have any doubt, please comment in comment box. I will clarify. Okay, so this is the EV introductions. So that's all. So if any doubt, need to ask. So next in 5 minutes, we can move to the next topic. If you have any doubt, so please ask in chat box. I will clarify you. So that's all about the EV introduction. In introduction, have any doubt means, so comment in comment box. I will explain you. Yeah, thank you. So next topic is vehicle dynamics. Okay. So vehicle dynamics is nothing but, so before we can going to design the EV, so this is a first topic. Okay, why we can why I tell like that? So for design the EV vehicle means we have to know how much power required to drive the vehicle. So what type of motor we can choose. So what is the rating of the motor. So how we can choose the battery pack. Okay, these are all things decided by the vehicle dynamics. Okay, so this is the full of problematics. So the chapter depend upon the problematics. We have to find the motor power. So we have to find the how much power required to drive the vehicle, and also how batteries we can choose. Okay, so in this topic, so this is the full problematics. So now we can see one by one. Okay. So vehicle dynamics is nothing but, so vehicle dynamics is nothing but when a vehicle moves to, so simply says means when a vehicle moves 0 to some speed. Okay, for that, how much power required to move the vehicle. So called a vehicle dynamics. So, okay, so we can see now also definition here. So how the vehicle moves on the road surface which under impact forces between tire and the ground. So simply says means how much power required to move 0 to some speed. Okay. So it working under second law of motion. So like second law of mechanics is working under second law of mechanics. Okay. So simply says how much power required to overcome to the zero positions. So called vehicle dynamics. So when a vehicle hold in on position, we have to move. So we have to move means how much power required to move your vehicle. Okay. So called vehicle dynamics. So these are the forces acting along the vehicles. So total name is total tractive force. So total tractive force nothing but vehicle exert on the surface amount of total traction is parallel to the direction of motion. So okay, so these are the subtopic of total tractive force. So rolling resistance force, aerodynamic force, grading resistance, angular acceleration. So angular acceleration have the two types, linear, angular. Okay, so these are all the coming under the total tractive force. We have to find the power. So power equal to formula of power formula equal to force into velocity. So here the force is total tractive force. So total tractive force means we have to this find this these four forces. Okay, these four forces sum means we have to find the total tractive force. We can see one by one what are the forces. So why it can be acting like that. Okay. So first one is rolling resistance force. So rolling resistance force is nothing but a transfer forces acting under the tire and the ground. Okay, so main thing is, so when a vehicle drive means so tire will be on the ground. So we have considered the what are the forces acting along the tire and the ground. So we can find. So here the two forces acting along the tire. One is normal force, so gravity force. Another one is a traction force, so opposite force. Okay, we called rolling resistance. So here the technical expressions. So the rolling resistance of tires on the hard surfaces primarily caused by the ices and the tire materials. Okay, so ices cause an asymmetric distribution of the ground reaction forces. Okay, so simply says means he have to two forces acting on the tire. So what are the two forces means gravitational force and the traction force. How to we can overcome? Okay, so that's the concept. So here the formula we where we can get this formula. So the phenomenon of result the shifting the ground reaction force means so slightly P equal to m into g. So m is the normally mass of the vehicle and the gravity force. Okay, so the rolling resistance moment formula TR equal to P into A. Okay, the force required to keep rolling means F equal to TR by RD. Okay, so already we can know. So TR equal to P into A by RD. We can substitute the TR here, P into A. by RD. So we have to don't know RD. So we can take the RD this side means. So we can take the RD this side means. So P into FR. Okay, here the P into FR. Here the FR is nothing. So here the F, right. So only is amount. So here F. So P into FR. Okay, so already we can know what is made P. So P equal to M into G. Okay, so M into G. So the formula is now Fr equal to, so here the caps Fr, force rolling resistance equal to mass into gravity into Fr. Here the Fr is the rolling resistance coefficient. Okay, we can see how we can choose the coefficient values on next topic. So just we have no, so Fr small Fr equal to rolling resistance coefficient. We can understand, we can give the small Fr caps Fr. Okay, we can give the whatever name. So the formula concept is mass into gravity into Fr for rolling resistance formula. So rolling resistance force. So this is the one of the force acting opposite the motion of the vehicle. Okay. So the coefficient value. So now speak the coefficient value means the coefficient is a function of tire material. So structure, temperature, tread geometry, road roughness, materials, absence of liquid on the road. So nothing but so we can select the coefficient value means so these are all the parameters we can consider. So coefficient value vary. So depend upon the tire material, structure, temperature, thread geometry. So thread geometry nothing but we can see in the front tire have the different pattern, back tire have the different pattern. Okay, so while because of front tire have the we need to turn left and right. So back tire have to need the more grip. So the button will be vary. So front tire button will be vary. So we can do the two wheel also. So front tire button it may be vary. Back tire button will be vary. So back tire create the more grip compared to front wheel. So the button will be vary. So that concept to another concept. But here we can consider the coefficient value depend upon the these parameters. Okay, this value varies the speed also. So tire pair increases, it value maybe decreases. So this is the coefficient values. Okay, when a car drive in concrete or asphalt road means we can take the 0.013. Or your car, the descent car driving rolled gravel means the tire is 0.02. Unpaved road means 0.05. You can drive in field means 0.1 to 0.35. Whatever the value you can take between. So when a vehicle drive in wheels on rail, so railway track means you have to the value taken means 0.01 to 0.02. Okay. So you have to find. So this is a coefficient value. So taken. So not only a value, you can search in the Google means you have get the more coefficient values. So rolling resistance coefficient, you have type means you give the more coefficient values. Okay. So this is the rolling resistance coefficients. So next one is aerodynamic drag. So next one is aerodynamic drag. So if a vehicle moves in air medium, okay, after the tire will be completed. So now we can come to the body. So car body. So when a vehicle moving in air medium, okay, it encounters the racing motion. The force surface is the aerodynamic drag. So it classified into two forms. So one is shape drag, another one is skin friction. So shape drag is nothing but so the car shape in top the car will be shaped denoted the shape drag because of in car moved in air medium so it creates the high pressure here so that time we can slope means the high pressure air flow into back so because of in back side there is a low pressure okay we can transfer the high pressure air to low pressure area so that is we can depend upon the shape drag. Okay, so we can give the shape drag give slopely means it will be vary. So the shape drag is completed when you air the vehicle skin produce a friction. Okay, the second component of the drag. So next we can consider the skin friction. Okay, so here the aerodynamic drag formula equal to FA. So force A aerodynamic drag. So half into rho into CD into A into V square. Okay, so half is nothing but zero point 0.5. So rho is air density. So air density will be vary depending upon the areas. Okay, in India, maximum air density 1.250. In Jammu and Kashmir, it may be vary. Um, so countries it may be vary. So in India, so in south side, we can consider the air density is 1.250. So area will be vary. So which area you have designed the car or vehicle means you have to choose the air density value in kg per meter cube. So A is the frontal area of designed car. So what is your frontal area? So we have to choose the frontal area. So CD is the drag coefficient. So V is the velocity of the vehicle meter per second. So here the velocity, how much speed we have to driven. For example, we have reached the 80 km means the velocity of the vehicle is 80 km per hour. So as a designer, we have to choose what is the maximum velocity of the your vehicle. Okay, so we can substitute meter per second because of force unit is Newton. Okay, so force in unit is Newton. Um, so that why we have substitute in meter per second. We can tell how we can substitute. But the velocity given in kilometer per hour, but we have to substitute in formula means meter per second. Okay, here the drag coefficient we have choose the coefficient values. So we can see in next slide. Okay, so drag coefficient of typical vehicles. So when shape in state means, so flat plate means the drag coefficient is 1.95. So CD is equal to 1.42 hemisphere. Here also hemisphere changes this side means 0.38. It will be sharp means 0.007. Okay, so you can see here. So the flat face, so the value is 0.85. So compared to this, it have to lightly slope. So slope value is 0.50. So compared to this, you have the more slope, so 0.45. So this compared to this 0.32. So the slope will be vary means, okay, the shape of the car bodies vary means coefficient value will be vary. So which type we have used means we have choose the coefficient value. Okay, for selecting coefficient two, we have to given this slide. Okay. For road trucks and train means, so you have to select 0.8 to 1.5. For buses means 0.6 to 0.7. So modified means 0.3 to 0.4. Motorcycles 0.6 to 0.7. You have to select the coefficient values. Okay, for the aerodynamic drag. So next one is gradient resistance or inclining force. Okay, so it is nothing but when a vehicle climb in a hill, okay, that time the weight produced by the component which always in downward direction. When a vehicle drive in upward or downward, so the car of the weight always acting in a downward direction. Okay, so the third force acting on the vehicle is gradient force. The third force is nothing but the opposite force. The third force acting on the gradient force, it occurs the vehicle driving on the uphill or downhill. When a vehicle driving uphill or downhill, we have to drive in the vehicle to this side. Okay, so this formula equal to mass into gravity into sin theta. How means how means when a vehicle acting in a inclined force in law of mechanics. So in law of mechanics, one force acting in the angle means we have to split in horizontal and vertical. So horizontal means mg sin theta, vertical means mg cos theta. So gravitational force and this force we have to zero. So gravitation, for example, gravitational force acting means 1. So mg cos 1 equal to 1. So sin 1 equal to 1. So 0. Okay, so that time, so m into g into sin theta. We have considered the m into g into sin theta. Here the theta will be the angle inclination. Inclination. So inclination of the road is the sin theta. So the total tractive force. So total tractive force, so already tell that the total tractive power equal to total tractive force into velocity. So what is mean by total tractive force means sum of these forces. So FRR is nothing but FRR rolling resistance, FAD aerodynamic drag, FHC hill climbing force, FIA linear motion, angular motion. Okay, sum of these forces is called a total tractive force. Okay, we have to find the total tractive force. We have to multiply with the velocity. Okay, we can see half into rho into CD into A to V square. So drag force M into G into FR. Rolling resistance M into G into sin theta. Okay, so here from the gradient resistance. Okay, so now we have seen the acceleration force. So acceleration is nothing but we have to due to continuous change of velocity with respect to time, acceleration also change because of at a highway, we can drive the vehicle at high speed. And inside the city, we have to drive the vehicle in low speed. So that time acceleration will be vary. So not in constant. So that time the force formula defined at the Newton's law, second law of motion. Okay. So the force exerted by the object equals mass time of acceleration of the object. So F equal to m into a. Okay, when a force acts in linear acceleration, so consider the F equal to m into a. So we can now substitute the formula. So m into a is acceleration, where the a is acceleration. So consider this dv by dt. Okay, so we have find the total energy consumed by the vehicle in motion means. So energy equal to integral of p tractive force into dt. So p track means nothing but tractive force. P tractive force into dt. Okay. So here the acceleration force definition. So linear acceleration force and angular acceleration force. So linear acceleration force equal to m into a. So now consider how we can choose means we can just find the rolling relation aerodynamic drag means just we can go with the linear angulation. Likewise, you can consider as angular acceleration means we have to go with the angular acceleration force. So how means so F equal to omega into A. So Ig square into A by R square into NQ. So I is nothing but moment of inertia. Where I get means from the area, the moment of inertia value we can taken from the area value. So G is the gear ratio. Okay, while using the gearbox in your vehicle means you have to just consider as the G gear ratio. So A is the acceleration, R is the tire radius. Okay, so radius of the tire. So NQ is the efficiency of the gear. We have choose the gearbox means that time we have to give the ratio and the efficiency. That time we can take it from the gearbox. So acceleration you have to give. Okay, so radius of the tire means which type of radius you can to give. So 12 4 or 17 16. So which type of you can use means you can use the tire formula. But formula is linear acceleration m into a. That time you have to use the angular acceleration force means I g square a by r square into nq. Okay, so this is the angular acceleration formula. Okay, so 5 to 10 percentage of linear acceleration will be the angular acceleration. So the vehicle driven by the motor through the gear means this is the formula P equal to T into omega. Okay, the vehicle is driven by the motor. So through the gear means we have to consider P equal to T into omega. Okay, the speed of the vehicle omega equal to velocity by radius of the wheel into gear ratio. So how can seen in here? So P equal to T into V by R into G. Okay, here nothing but T is the torque. So V is the velocity of vehicle by R is the radius of the wheel. So G is the gear ratio. Okay, if we have to find the critical velocity of the equations, so you have the program in MATLAB, we can substitute means you have to find the critical velocity. Okay, so this is a unit conversion here. Power equal to torque into velocity. So P equal to watt. So torque equal to Newton meter. Omega is unit radian per second. So watts equal to radian per second. So where n is the revolution per minute in RPM. Okay, n is nothing but RPM. P equal to watt. Okay, so P equal to watts. Okay, so this is the question. So I hope you are understand the concept. So if you have any doubt in concept means you can chat in chat box. I will clarify. So next I will go with the sum. Okay. So if you have any doubt, okay, so just start in chat box. So we have to go to the example sum. So if you have about the example sum means you have to some ideas. Okay. So if you have any doubt means so please comment in comment box. Oh, Ajit Haji. So last out. So it is depending upon the battery capacity. Okay. So why to do long range means you have to only the battery capacity. Okay. So battery capacity is very high. So for a 6 volt battery, so drive range is 100 to 120 kilometer. Okay. But in IC engine means you have the more mileage. Okay, so we have to drive range very long. So nowadays we have to use the battery. So 400 kilometer range is also available. So we are working on it. We have to increase the battery capacity and long lasting. That time we can get the more long range. But in future, compulsory we have to get the more battery capacity to drive the long range. Okay, so compared to previous years, so we have to reach the long range. Okay, for take the Tesla, we have to drive ranges near 1,000 kilometer, 1,200 kilometer. But in India, we have to give the 400 to 500 kilometer range. Okay, so 400 to 500 kilometer range only. So Ajit, you have to hope you have to clear the doubt. Okay, so regarding this topic, any doubt means you have to clarify it already. So no doubt means you have to go with the next topic. Next topic means example sums. So example, we have to understand this concept very easily. Okay, if there is any doubt means you can please comment in no doubt. We have to move the example sums. Do you have any doubts? If there is any no doubt means please comment in comment box. No doubt. We have to go with the next. Okay, I hope you have understand the concept. So now we can see the examples. Okay. So electric vehicle dynamics. Okay, electric vehicle dynamics. How to find the calculations. So here the concept. So this is real-time calculations. In industrials also, this is the steps we can follow to find the motor power. Okay, what type of motor we can select. So for this motor, how the battery pack you can choose. So same concept also used in industries. Okay, so this vehicle dynamic calculation, we have the version one vehicle in Pantech laboratory. Okay, so that vehicle calculations here. So we can see in Pantech channel one shots are available in EV. Okay, so first type version one EV you can not seen means you can see it. So that vehicle data here we can show on. So for that we can design the vehicle for same manner. Okay, so first one is mass of the vehicle. Okay, so mass of the vehicle is 280 kg. So width of the vehicle is in mm, 705 mm. We can consider into meter because of for unit conversion we have to substitute in meter. So height of the vehicle is 1080 mm, so 1.8 meter. So length of the vehicle is 1950 mm, 1.9 meter. So F for coefficient value, so we can choose the rolling coefficient value 0.013. So air density in India, so south side, so 1.25 kg per meter cube we can choose. So CD, okay, so 0.0300. So area equal to 0.76. So meter square. So gravity 9.81. So angle inclination is 6 degree. So tire radius is zero point 0.3. Velocity equal to 90 kilometer per hour. We have to change in meter per second. I have to tell how to change. So this all the data we can take it from the vehicle. So this is not fake data. So in Pantech laboratory we developed the version 1 car. That car calculations for here. So after that we can download the two EV cars. So that clock is also available. But yes, the first week is gone. So for this data, how much value is given from the motor? So that motor we can choose. For that motor, we can choose the battery pack and the control also. So this is very important topic for designing the electric vehicle. Okay, if you have any doubt, means feel free ask to in chat. I will explain the or clear the doubts. Okay. So we have to find the power. Okay, we have to find the power. How much power required for this the vehicle? So the power formula equal to I already told the power formula equal to force into velocity. Okay, we have to find the force means power by velocity. So here the power equal to force into velocity. Here the force considers a total tractive force. So here the force considers a total tractive force TTF into V. Okay. So what this mean by total tractive force means sum of these forces. So aerodynamic drag, rolling resistance, and the gradient resistance. Okay, so we can see in here. So we have to first to find the aerodynamic drag. So aerodynamic drag nothing but so FD equal to half into rho into C into A square. So for that we have substitute the values. So half zero point 0.5 rho 1.250 CD 0.330 A 0.76. So V square. So V square means velocity. So we have to substitute in velocity kilometer per hour. We have to substitute meter per second. How means? So kilometer to meter. Substitute means 1000. So hour to seconds. Okay. So hour to seconds. How convert the hour to seconds means? So hour to minutes for 160 into minutes to seconds for 60. So 60 cross 60 equal to 3600. So we have to substitute the 3600 by whole square. So we have to convert the speed. So meter per second because of unit Newton. So for that we have substitute the meter per second. Okay, in this way I can convert. Or otherwise other small aptitude test. So also available. How to convert the kilometer power to meter per second means 5 by 18. 90 into 5 by 18. Okay, so that's also small shortcut 5 by 18 is the shortcut answer. So directly you can substitute in kilometer per hour in meter per second. So 90 into 5 by 18. So this value come. So how to check that type also. So now we can simplify. So zero point 0.5 you can multiply this value. So get 0.142 into 90 divided by 3.6 whole square. Okay. So here the 0.140 into 625. So we have to substitute. Okay, so we can get the 89.179 Newton. Okay, for this concept means we have to record force. Okay, for your vehicle. So how much force required to clear the aerodynamic drag means so 89 Newton. Okay, 89 Newton. So you have to record force is 90 Newton for your vehicle 0 to some speed. We have to move 0 to some speed. With the opposite aerodynamic draws required force is 90 Newton. Okay, 90 Newton record force. So next one is rolling resistance. So rolling resistance is nothing but M into G into FR. Okay, here the M is 280 mass of the vehicle, G is 9.81, FR value 0.013. Okay, we have to simplify means here I'll get the 35 Newton. Okay, so this is the record force for more vehicle 0 to resistance. If the need force is 36 Newton. Okay, same concept. So required force is 35 Newton. Okay, 35 Newton required to move your vehicle 0 to some speed. So next one is gradient resistance. Okay, next one is gradient resistance. So gradient resistance is nothing but m into g into sine theta. Okay, here the m into g into sine theta. Okay, for substitute, but we can simplify. Before simplify means we have to convert the theta degree into radian. Here directly due to the 6 degree, but you have to change in, but you want change in radian. Okay, you have to change the radian. So mass equal to 280. So G equal to 9.81. So sine 6 degree means you have to change in pi by 180. So 6 into pi by 180. You can get the radius value. So radian, sorry, radius value, radian. Okay, so that radian we have to simplify with the sine theta. So first step, you have to convert the degree into radian. So 6 into pi by 180, you can get some value. So that value compared with the multiply with the sine theta. So one value given. So that value you can multiply with the radius means it will be correct. So otherwise directly 289.81 sine 6 you can get means answer will be wrong. So we are compared to the means the answer will be wrong. But you have to correct way means so you have to first convert the radian. After that you can simplify, answer will be correct. Okay, here also after you can convert the radian you can substitute here, but you directly 289.81 sine 6 put means you cannot get this value. Okay, so we can find the three forces. So now we can sum of these three forces. Okay, 89, 35, 287. We have to sum of these three forces. So total tractive force equal to 412.006 Newton. Okay. So now power equal to total tractive force into velocity. Okay. Now the total tractive force into velocity. So we have just directly substitute the. So how we can simplify means so 1000 divided by 3600. So 1020 3600 2030. So 10 by 3.6 we can simplify it 3.6. So that time we can simplify here. Okay, same way we can simplify here 3.6. Okay, so record force is 1030 60 watts. Okay, so the total power equal to 1 kilowatt. We have to just convert the kilowatt. So 1000 means we have to divide to 1000. So 1 point. So the total power required to move your vehicle. So okay, if you want the vehicle move means you have to record the 1 kilowatt motor. You have to record. Okay. So this is the vehicle dynamics concept to choose the motor. For we can choose the 1.4 can see. So we can choose the 1200 BLDC motor hub motors. Okay. Now we can design the motor for 1.2 kilowatt power. Okay, so why we can go with the vehicle dynamics, we have to find how much power required to move your vehicle. So for this data, so required power is 1030 watts. Okay, in kilowatt means 1 kilowatt required to move your vehicle. Okay, so can I hope you understand the concept. If you have any doubt means, so comment in comment box, I will clarify you. Okay. Please comment in please comment in comment box. If you have any doubt means you have to clarify it. So you have to go to the next design of motors. So how to find the critical velocities. Okay, so comment in comment box if you have any doubt regarding. There is no doubt means you have to go to the next topic. Okay, so there is no doubt, right? Okay, so next we have to select the motor power. Okay, we have to select the motor power 1200 watts of BLDC motor. So for the 2.1.2 kilowatt motor, we have to choose the data. So what are the data required from the motor side means I have seen in next slide. So motor certification name is T Suya. So volt is 48 volt. So the rated power is 1200 watts. So rated speed is 3000 RPM. So torque equal to 20 Newton meter, right? So we already know. So power equal to torque into omega. So here the omega we have the another formula. So this formula is nothing but how much torque delivered by the motor first per second. Because totally we have to deliver the total. So total torque is 20 Newton per meter. But how much torque developed by the motor per second? Okay, we have to find means. So omega equal to 2 pi n divided by 60. So 2 pi n nothing but RPM. Okay, so 2 pi we have to know 3.14. So n 3000 RPM. So by 60. So we have to 314.15 radian per second. Okay. So maximum torque produced per second is 314.15 radian per second. Okay. So it motor deliver the T max. So motor will be deliver the T max equal to 3.14.15 radian per second. Okay. So the vehicle driven by the motor. Okay, the vehicle driven by the motor power through the gear equal to speed of the vehicle. Okay, so speed of the vehicle equal to velocity by radius into gear ratio. Okay, so P equal to already know I mentioned the slide. So P equal to T into omega. Okay, here the P equal to T into V by R into G. Here because of the omega formula, V equal to R into G. Okay, so we have to find the velocity cricket because of I don't know the velocity of a motor. So we have to find the critical velocity of the motor. So we have known values for how much power. Okay, we have to know how much power required. So 1200 watts. So torque is 20 Newton per meter. So gear radius so zero point 0.3. You have to know the radius of the zero point 0.3. So gear ratio. How to choose the gear ratio is 9 is to 1. Okay, we have to choose the gear ratio is 9 is to 1. Okay, so we can substitute the 9. So 9, how we can choose the 9 is to 1 is so nothing but so 9 is to 1. So 9 gear rotation frontward. So 1 gear is backward direction. So reverse gear. Okay, so sets so totally 10 gears. So 9 gear sets we are no rotation in one direction. So 1 gear rotation in another direction. So that's called radius of the wheel. So sorry, gear ratio. So we have to simplify that. So we have to simplify that. So we can substitute the value. So P equal to 1200, T equal to 20. So 30, we have simplified 30. So V equal to 2 meter per second. Okay. So we connect the motor. The vehicle will be picked up in 2 meter per second. Okay. So that is the critical velocity. So critical velocity of the motor is 2 meter per second. For the 2 meter per second, vehicle will be moved to 0 to some speed. Okay, so concept is the vehicle moved. Okay, so 0 to some speed is 2 meter per second. Okay, so the motor deliver the critical velocity is 2 meter per second. So now we find the initial acceleration assume so t equal to t max. Okay, so here the formula. So we can consider the acceleration. So angular acceleration formula. So nq into g by r into t max. Okay, so these are all the integral. So integral by dv by dt. So this formula moment of inertia. So we have to simplify that. We have get the value 320. If any doubt means you have get from the values. So 320 dv by dt. So nq is the efficiency of gearbox. So 0.89 because of 89 percentage. But we have substitute means in not a percentage. So I have to simplify 0.89. 0.89. So G by 9 gearbox 9. So radius of the wheel T max equal to 20. Okay, so we can substitute the FR value, mass value, gravity. So 0.652. So half into rho value. So we can simplify 0.652. So CD into A into V square. We have substitute. So because of don't know the velocity, we have to find the velocity, right? So 320 equal to dV by dt. So how we can simplify that? So we can simplify that means 334. So if we have to simplify this one means 35.780. We have to simplify this one is also 0.14. So only 320 dV by dt. Okay, so 5. Okay, so now we can simplify. So we can find out the dv by dt. How means? So first step is we have to get from the 35 708 this side to this side. So we have to get the minus value. So 534 minus 35. So we can here. So another value is here. So next, so 0.02 go this side. So 498 minus 0.14282 v square. So this side is 320 dv by dt. So after that we have to find the dv by dt. So this multiply this side. So come to this side means the value will be divided. Okay. So you have to divide by the both value in 320. Both value in 320. So divided by 320 means 1.557. So divided by this value means 0.005 v square. So it is the equation 1. So now we can find the dynamic equation. Okay, here we have to find the torque. Okay, this is dynamic equation. We have to find the torque. So same formula, but you have to find the torque also. So we can simplify. So 40 V by Newton meter. So the maximum torque delivered by the motor is 40 by V by Newton meter. So now we can consider here the T equal to T max. Okay, now we apply the torque value in formula in dynamic equation. Okay, so NQ G by R equal to T max. So equal to FR into M into G. Okay, so same formula, we have to simplify that. So same formula, we can just simplify. So same procedure, we have to simplify. So answer get is 3.3 by V minus 0.00158. So 0.005 is this equation 2. Okay, for torque one, let's consider as a 20. So here we can consider as a 40 by V. We have to find means we have to find the critical velocity of the car. Okay, for your designed car. So now we have opened the MATLAB. So here we can open the MATLAB. Yeah, already open. So give time to open. Yeah, okay. So here the program. So MATLAB program. So MATLAB have the three chapters, three types. So first one is the scripting program. So scripting program is so here the script program. So next one is Simulink. So here the Simulink. So inside the Simulink have the two types Simscape. Okay, so first we have the script programming. Here we can give the program. Okay. So what is meant? So equation one we can do substitute here. So equation two we have to substitute here. So dynamic is equation one initial acceleration value substitute here. So dynamic equation two we have to substitute here. So already we can substitute. Okay, if you have need change means you have to need. So here the what is the value for that value we can plot in graph. So plot t and v. So time and velocity. Okay, so x label. So time in seconds. So y label velocity in kilometer per hour. Okay, so this is a formula. Okay, so just you have to run the simulation. That's all. Okay, just you have to run the simulation. So to get the velocity. So I click the run. Yeah, okay, it will be done. So kilometer. So maximum speed is 70 kilometer. So time is 13. Okay, so the critical velocity is 13 second. When a vehicle reach the 70 kilometer per hour, so the critical velocity, after that you drive normally. But this is the critical velocity. Okay, for first 13 second, the motor drives in critical velocity in 30 second. Okay, so we can find the time, right? So 13 seconds. Okay, so we got the critical speed for above equation for 13 second. So already I told 5 to 10 percentage of linear acceleration will be the angular acceleration. So the power work done by the period of time is kinetic energy. So the formula is power equal to work done by time, right? So here the work done formula equal to half into m into v square. Okay, we know all the values. So half value. So m is the mass of the vehicle, v is the velocity of the vehicle. So now we can substitute in formula, power formula. So power equal to half into m into v square. We can substitute the value. So half into mass of the vehicle. So velocity of the vehicle by time. Okay, we can simplify means we can get this value. So 6,000 watts. Okay, for this motor, we have to drive the vehicle means. So the total power is 6,000 watts record. So record power is 6,000 watts. So we can choose the 6 kilowatt battery. So 6 kilowatt battery we can record for to drive this the vehicle. Okay, for this data, so the record power is 6,000 watts. So we can choose the 6 kilowatt battery to drive the vehicle. Okay, so this all the concept. I hope you are understand the vehicle dynamics concepts and introduction of EV vehicles. So have the courses in LMS also. We have the same courses in LMS also for 30 days for about the motor controller. So examples, MATLAB simulating. So what are also available in PPT. So you can see in there. Okay. So some free courses are available. So just to open YouTube. Okay. So in YouTube you have the shorts also. Okay. So where's the data we can get from is so or something that you can just search EV Pantech means the shots will be shown. So this is
Hello everyone, this
the
is EV
data.
prototype
Okay,
developed
so
by
this is the
Pantech.
data.
Its specification is
So
rear wheel
first made by
guided dual
the
drive system,
Pantech.
maximum speed up to 20 kilometer, range up to 40 kilometer, charging time is 8. Hello everyone, this is EV prototype developed by Pantech. Its specification is rear wheel guided dual drive system, maximum speed up to 20 kilometer, range up to 40 kilometer, charging time is 8 hours. So this prototype can carry up to 300 kg with regenerative braking, tested completely in Pantech laboratory. If you want to build the similar prototype with different motor, Pantech will help you. In EV Design Masterclass, you will get a complete step-by-step process. If you want more information, please visit our website pantechelearning.com. Thank you for watching this video. Please like and subscribe this channel. Hello everyone, this is EV prototype developed by Pantech. It's special.
Okay. So okay. So if you want any doubt about the EV means, so you have to feel free to ask. Okay. So I hope you enjoy the session. So thank you for your valuable times. If you have any about means you have to ask. So feel free to ask any doubts. So if there is no doubt means you have to end the sessions. Uh, okay, if you want to know about the EV means you have the also EV courses. So you can get to learn from that. So team will be always support you. Okay. So I hope you enjoy the sessions. So thank you. So thank you.